So
Cool.
I get, oh, sorry.
Yeah, no, did you want us to give a rundown of Nimbus, or 101 on Nimbus, or how did you want to get started?
I was thinking it might be good to just see where everyone is at when it comes to using Nimbus.
Is everyone able to have logged on to the dashboard or spun up an instance? Yeah, it might be a good way to go. Yeah.
We've got one thumbs up.
There are a few gotchas the first time you spin up an instance, like not putting SSH security group in when you are creating it. I did that the first time I did create an instance.
So by default, when you create an instance, it's like completely impenetrable. So it's purely through the addition of the security groups that you add your access into how you want to do it. So the first thing we always add is the SSH access, so you can actually connect into it.
Hi, my name is Brittany. Is it okay if I start just throwing some questions in? I've already got my instance set up.
I'm fine with that, sure.
Okay, cool. So I was allocated an instance with 10 terabytes of storage, but I'm not sure where to access that storage. So when I set up my data volume, I believe I have 40 gigabytes left. So I think my operating system that I put on there takes up about 40. So my question is, do I access the 10 terabytes separate from the Nimbus dashboard? Is that through Acacia?
Sorry, I'm just having a look. Yes, so for your project in particular, which is Interns 2203, I can see that, yeah, all you've got as far as local storage to Nimbus is enough for the root disks for the instances that you're spinning up. So the 10 gigabytes of storage you've got is would be an Acacia. I'm assuming that's been already set up, Luke?
I can
10 terabytes?
10 terabytes.
Sorry,
yeah.
10 terabytes.
Yeah.
You'd burn through 10 gig a little too quickly, I think.
Yeah, because one of my first points of order is to import like 95 gigabytes of genome data, and I'm looking at it and I'm going, I don't think it's going to fit.
Okay, so
yeah.
I don't know how much you've been told about Acacia storage, but just so you're aware, Acacia storage is object storage. So you'll be treating it differently to, like, for example, when you spin up a volume on it, attach a storage volume on instance, which would be like your traditional POSIX file system. We do have documentation on how you would access Acacia object storage from within your Nimbus instances. So
you're just checking your origin there. So you got 1 terabyte of Acacia at the moment.
Okay, so that'll need to be upped then, presumably.
I can do that right now.
Cool, thanks, Luke. So yeah, the link I've just put through into the channel there is our documentation on how you would access and use the Acacia storage from within Nimbus.
So if I was to import my like a whole lot of data that probably won't fit on the volume, would I put that through Acacia? And how would I access that if I want to run something on it through Nimbus, if there's too much data?
No, so typically we would use Acacia for how we would do for normal Nimbus projects is Acacia is tended more for like your longer term storage. So you'll still presumably require some level of local storage on your Nimbus instance for like a working space or screen space, whatever you want to call it.
Provide a bit more.
So if you like, for example, want to be able to create a data volume that you then attach to Nimbus, and that just gets treated like an attached disk of local space, absolutely, we can increase the volume storage quota on your project for you. You just need to let us know how much you would like for that.
Would like 200 gigabytes be okay?
Yeah, that's fine. So I will update your project now.
It's first class service.
Yeah.
We try our best.
I guess a question I have about using Acacia on Nimbus. So as I understand it, like on say Sotonix or Topaz, we'd use the min.io client, right? Most
Yes.
easily to
Yep.
transfer the data from Acacia to Scratch while we're working on it, and then once we've finished working, transfer it back for longer term storage. Now, if we have a Nimbus instance, it seems to me that it's the easiest way to get up and running. Would that be to install the min.io client?
Yeah. So
In
it's
my
pretty
instance?
much you're following the same, very similar process.
It should be its default, shouldn't it, Jeremy?
If you are using the
I thought that was
Pawsey provided images of certainly at least the Ubuntu ones, Ubuntu 18 and Ubuntu 20, I believe they by default have the, I might be spinning lies. Let me just, yep. So MC is, which is the min.io client, is already installed by default on any instances that are spun up using the Pawsey provided Ubuntu 18 or Ubuntu 20 images. So all you need to do is provide your configuration to point to whatever the Acacia storage is relevant. If you look at the documentation that I've linked you, that should explain how to do that. Oh, okay, yeah. So basically our document on managing Acacia storage points you back to the main Acacia user guide for setting up your min.io config. But basically, if you follow that, let me link the main Acacia storage guide. There you go. There'll be a section there on how to set up the min.io client, in particular to point to your Acacia storage.
Quick question.
Yes.
Sorry, how can you see? Sorry for the weird camera angle, by the way. I'm like, don't have any furniture yet. How can you? How can you see if you have Acacia storage assigned to you? Is that through the Pawsey dashboard?
The Acacia. Oh, sorry, Luke. You.
Yeah. So you would have to log into Origin. So I'll put the link to that. So they are separate. So your Nimbus dashboard and Origin. So Origin is the back end that we use in terms of permissions and other boring stuff. I'll put that.
You just muted yourself, Luke.
Sorry, I'll
just put that in the chat.
Yeah, I'll put that. Oh, you have?
Is that the same login as the Pawsey dashboard?
Yes. So
okay, cool.
Just to be clear for everyone else, you'd have the Nimbus dashboard, like managing your instances. If you're an admin, which you probably are in your account, and then there's the Pawsey Origin dashboard.
Yeah, that's totally different. Yeah, but they use the same password and username. Yeah.
But yeah, so the Acacia storage is not immediately visible from the Nimbus dashboard. That's what you go to Origin for to look at that.
Yeah, and that's where you get your key and all that stuff that's in the documentation for Acacia. So
Brittany, just FYI, that 200 gig of additional storage should be available to your Nimbus project now.
That'd be a pain in the butt and ask for 500.
That's fine. Not a problem.
Something that I wouldn't mind adding, you guys were saying about the setup, is that when it comes to setting up the min.io client, I was pleasantly surprised to find that when I stepped through creation of the keys that you'll need, so the documentation will talk about the key generation. At that step, in Origin, you're actually provided with commands to copy and paste into whichever system you're using. If you're using MinIO, and that'll just set up all of the variables to point to your storage.
Yeah, just cut and paste. So that is a good feature where I know sometimes when they say just do this, this, and this, but they don't actually give you examples. So you kind of hack around until you get it right. But, it's literally just cut and paste whatever is there.
So if we want to move data from a volume to Acacia, we use the MinIO client to do that.
Correct.
And backwards and forwards as well. Okay, cool.
Yep. Yeah, so your quote has now been updated with the additional 500 gig now.
Yep. And
Great, thanks.
That's all right.
And you should have 10 terabytes of Acacia storage as well, but that takes a little while to update through Origin.
I have another question. So when I went through to create my test data volume, in the tutorial, it has, I don't actually know what this means exactly, but it's been attached to, in the tutorial, it said dev/VDC, but mine's attached to SDC. Is there a problem there? Is it okay if I use SDC, or will that be causing issues? I looked at it a little bit. Apparently it's because of speed or something, like VDC.
No,
So it's updating the documentation. That's what it means.
No,
oh, okay.
No, okay. When did you read the documentation out of curiosity?
Yesterday.
Oh, curious. Okay, because it should have already been updated from like last week. So you'll see
the video or the actual documentation on Confluence.
Oh, so this was just the I guess the link, the Pawsey support link, how to set up Nimbus. That's the one I was on.
Okay, so I'll link. There's another one for you to show on, which goes through how to set up and attach your data volumes in Nimbus. So that's probably going to be a bit different from what you may have read or watched, or this version there, but that's the most up-to-date version of the documentation. So the naming of the devices is to do with a change that we made back in May in Nimbus, which is how it handles the disks as they are presented within the operating system. I don't want to get too bogged down in the details, but the bottom line is if a disk appears as like VDA or VDD, then it's being presented as a virtual disk, and that uses a different system to perform IO on it compared to a disk that appears as SDA or SDB, which is, as far as the operating system is concerned, appears more like an actual physical disk.
Okay. Yeah.
So yeah, SDC, as it would appear normally, is how it would appear for attached storage disk now. But
okay, cool.
I will also draw your attention to a fact that an unfortunate side effect of this moving to how we've managed this means that when you reboot your instance, those names will probably get shuffled around, which is a bit annoying.
Okay.
And so again, if you read through the documentation, it'll tell you all about that. But basically, when you're mounting the file system, you want to use the UUID for the file system rather than the /dev/SDC or whatever.
Yeah.
Just wanted to give you a heads up on that. That's all, because that's a bit of a gotcha that we've encountered recently, and we just want to make sure people are aware of that.
So that will be in the new documentation showing
that's
how
all
to do that.
That's all detailed in that thing that I just linked.
Cool, great.
No worries.
Any tips to best optimize the Nimbus instance? Or best use it, I should say.
In what respect? Sorry, optimize how?
So I guess make best use of the resources for a given project. I'm not.
That's probably going to boil down to what exactly it is that you plan to run on it. Now, I'll be honest here. I'm not a data scientist. I probably am not the best person to speak on, optimizing your pipeline and things like that for how you plan to run stuff on the instance itself. So which project are you with, Kevin? Sorry.
I'm with, I think it's 2204.
2204. Yeah, okay. So your project has, okay, so you've got resources for spinning up to two 16 core instances. So yeah, look, there's nothing particularly crazy about how to go about that. You just fire up the instances and off you go.
I'll put in.
Wait, so two separate instances?
You can create two separate instances, and they will have 16 core and 64 gig of RAM each. That's the quota that for your particular project.
I think that was updated recently. Actually, I think it's now 128 gigs in a single instance with 2 terabytes of storage.
You are correct. I apologize. I'm looking at the wrong line.
Good.
I'm looking at the wrong line. Yes. So yeah, you can spin up one. Basically, it's the same resources. It's just combined into one instance. So 32 cores and 128 gig of RAM. So yeah, there's from an operations side, it's just spin up your instance and off you go. I would certainly recommend, as far as disk storage for your instance goes, typically our recommendation is stick to the default 40 gig for the root disk, and then however big you want the attached data volume to be as essentially your workspace, attach that as a separate disk. We recommend that for a number of reasons, primarily because we've had more than a few occasions where someone's been using the root disk to store users their workspace and happen to fill up the disk, and all of a sudden their instance is no longer accessible because all the services start failing because they've run out of disk space. So safest option there is just simply have your work all in a separate disk. So if that fills up, the instance is still just going to keep running fine.
So I'll put a link to best practices as well.
Oh yeah, there you go.
So,
so just following through the tutorial, the documentation.
Yep, absolutely. And of course, if you encounter any other questions, don't be afraid to send an email to help@Pawsey, and one of us will get onto that and have a look.
Great. Thank you.
David, you raised a question about FS tabs versus auto mount. We don't have a particular preference one way or the other. I mean, normally we tend not to tell people about it, but if you want to stick an entry in FS tab, that's absolutely fine. Again, we recommend you use the UUID for the file system, just in case. The main issue that people have had is obviously at boot time, if for whatever reason the operating system can't find the disk it's looking for, it'll just fail over into maintenance mode. And so at that point, then you're going to have to get in there and manually hack your FS tab file to either comment out the disk that it can't find or change it to the correct thing. So if you use the UUID for the disk, even if the device name changes, you'll still be fine because the UUID won't change. Again, if you look in the documentation, that'll tell you how to find the UUID for your file system. Oh, sorry, you've gone quiet.
Zoom doesn't like my microphone and auto sets it to stuff.
Oh, okay, no worries. Sorry, could you repeat then what you...
Do you have a guarantee for uptime for those network available volumes or, well, virtual disks? Because I can imagine even if you use the UUID but things are down, you're still going to fail over.
Sorry, when you say guarantee of uptime, you mean for whilst the system, while your instance is running?
Yes. Well, because instances can also reboot due to failures and everything else. And
yes, that's correct.
And so I'm just wondering, like, what are the, it's like, is it possible to, because your user documentation does explicitly just say call sudo mount, which will modify it, well, won't modify fstab, but you can set it to do so. And it's like, is there an occasion where it will still fail over even if you're using the UUID because of various services being down?
Not that I'm aware of. I mean, as far as like general uptime for Nimbus itself, it's usually pretty good. There have been, admittedly, very rare occasions where a compute node has fallen over for one reason or another. And typically when that happens, your instance will restart the next time the compute node comes back up. And so then it'll obviously go through its boot process, which will include mounting whatever's in fstab. But as long as there's no disruption to your instance, then yeah, there shouldn't be any issues there.
Okay, thank you.
No problem.
Just wanted to add to Kevin's question about best practices. Just a very general thing that maybe some people haven't thought of, and that just to be that really encourage you to do things like getting a Jupyter notebook. Jupyter notebooks set up, like remotely accessing them and working in them, if that's something you're doing on your local machine, right? So you can have that workflow. You can access your instance remotely. You can also use things like screen, so the Unix command to do multitasking, right? To have multiple terminal windows that you can come in and out of, and also leave processes running when you actually close out of a terminal window. So yeah, if you're new to it, don't let yourself be constrained by just that one terminal session. You actually have all of the flexibility you'd normally have with a workstation that's like sitting right next to you.
Screen I can recommend especially useful for if you like to do really ugly brute force things like running back shell scripts or whatever from your command line to get certain stuff running. At the very least, if you're doing it in a screen session, then you're not going to be impacted by if you need to log off, or if you're accidentally disconnected, you can just jump back in and resume again next time. So yeah.
Another question. This is more to do with the difference between like the Nimbus instances and Cetonics. So with the Nimbus instance, as far as I understand, like we just have our own sort of 128, whatever our allocations are, and we have access to that all the time.
Yep.
So while that like is good because there's no like set core hours assigned to us, it can also mean that we can't perform as much work within a small amount of time if there was a bit of a time crunch. So is that something to consider when like scheduling our projects, making sure we, I don't know, give ourselves more time to run our programs or whatever it may be, just because you can't use, as many cores as you need to using the Cetonic system?
Yeah, look, the trade-off is certainly that, like, obviously with Cetonics, you've got a lot more power at your disposal, but you are limited to certain windows. My only real recommendation there is to do more of a bit of a suck it and see approach, where you can just try running smaller tasks to begin with on your Nimbus instance and just see how long it takes. But yeah, absolutely. As far as when you're handed your project, you spin up your instance. Yeah, you can, well, outside of obviously the time constraints for this internship, but ordinarily, as far as a standard Nimbus project goes, yeah, you run it for as long as you need to, kind of thing. We do a review every 6 months for a normal Nimbus project to sort of check and see, hey, look, give us an update, how you're going, do you still need it, that sort of thing.
Great. I guess a follow-up question from that is, with Cetonics, there are like, I guess, optimization criteria when it comes to trying to maximize like efficiency and the core hours you're using. Mm-hmm. So we covered that briefly in one of the workshops. Is that not really as big a concern when using a Nimbus instance? You just sort of try to use as much as you can.
It's not something we enforce, put it that way. I mean, you know, you've got an instance up and running, that's the resources you've got access to. You're not limiting anyone else if you're just sitting idle on that and not doing anything with it. I mean, that said, obviously we encourage people, hey, look, you know, you've got it, you may as well make use of it, you know, while you can, kind of thing. But there's nothing there that specifically states that, you know, you've got to be, you know, maximizing your use of the instance for as long as it runs. I mean, we've got some people who, as one example, will have the purpose of their project is to run a front end to a, you know, a database of whatever kind. So it's people basically hopping on to a web front end to run queries on it, on the data that's provided to that system. Now, it's not a common use for it, but certainly we do have some projects that do it that way. And so they're not really sort of, you know, trying to push the CPU core hours on their systems, for example. That's pretty, you know, low intensity use.
Okay, cool. Thank you very much.
Yeah, no problem.
I have a question about running, like if I wanted to run the same job on like 90 genomes at the same time, is that possible on Nimbus, or is that more of a supercomputing thing? Because do you like log into a node and then send jobs out to multiple nodes on Nimbus, or is that something you can't do?
You can set up something like that if you've got the resources for it. In the case of these intern projects, it's literally what you spin up is what you've got. There's no back end of additional nodes as presented to you within the, you know, your Nimbus project that you can then access. Okay. So again, caveat as before, I'm not a data scientist, so I can't say what the load requirement would be for 90 genomes. We do have other people that could answer those questions. They're just not available at the moment.
Ask if you have questions like
yeah,
that.
absolutely. So for stuff more along those lines, is, you know, what do you, if you wanted to ask others, hey, what do you feel is a, you know, suitable requirement, sort of in terms of number of cores, amount of RAM for being able to perform, you know, X task with genomes, absolutely, you can submit those to our help desk, and we can get someone better versed in those kinds of questions to answer you there. But as far as, like I said before, literally what you've got access to within your project, those are the compute resources that are available to you within Nimbus.
Okay, cool. So if there was a case where I don't have enough available, that could be modified?
Sure.
Okay,
if
cool.
I mean, we've had people who've, you know, come to us before and go, look, we've fired up this project, you've given us, 4 8-core instances, but that's not really enough. We'd like, we'd like to double that if we could. And depending on what your request is like, we can sort of query, you know, what is it you're trying to do here? And then we sort of work out, you know, yeah, that sounds reasonable, or, you know, maybe we should try this instead. And then, yeah, we can certainly increase the quota on your project so you can spin up more instances. Or if you prefer, you can resize an existing instance to a larger one. So you don't even need to delete it. You can just, you know, magically turn it into a bigger instance.
So I could just create a bigger instance and then just run multiple algorithms on it at the same time, speed it up a little bit.
You can. Some workflows operate better if you've got multiple smaller instances and they just run in parallel.
Okay.
And in those situations, what you can do is you can create basically a cluster of smaller VMs, and then you'll have one VM that you've spun up as your head node that then does the management of tasks across your mini cluster. So, for example, you could use Kubernetes to spin up a cluster if you wanted to in that respect, which we do have some documentation on if you were interested in going down that path. But in a lot of the cases, we would probably need to then modify your quota to allow you to do that. But that's, yeah, certainly doable.
Cool, thanks. Would you mind putting that into the chat as well? Some documentation on that.
Oh, sure. Let me just dig some up.
I'd like to add a point I guess, to your answer, Jeremy. Feel free to like to hear your opinion on it as well, right? It's just as a Nimbus user.
Yep.
So when you're first starting out, I would say that if you're working on an instance with 16 cores and you have some program that does run with MPI, so it's the sort of thing that you might run on Cytonics, if all of those processes, parallel, processes are pretty much independent, then, if you have 16 cores, run 16 MPI processes as a general rule of thumb if you're not doing anything else with that instance. And that'd be my starting point. So if you want to run 90 genomes in parallel or whatever, then you could do that. So 90 genomes per core, assuming that that's not, already making use of OpenMP or something else. But yeah, it's that basically, you have a cause, you can assign those cores to an MPI process. If you were working with MPI, it's just you have a smaller number of cores and a single node.
Oh, so I could make each of my cores run the same algorithm, each one within my instance, and then that could kind of make it parallel as well, just on a smaller scale.
Yeah, that would work.
Okay.
Though I do, Jeremy, I think your point right about running multiple instances is actually, there might be a better way, especially if the code you're running already makes use of multi-threading. So you'd want to check, I guess, to see that you're not interfering with that.
Okay.
Yeah.
So I guess, sorry, you go ahead.
So I was just going to say, forwarding on from that as well is one thing that we do recommend to Nimbus users is, look, it's the old pets versus cattle. If you want to use your project resources to spin up a bunch of small instances and try that out, and it doesn't work quite the way you want to do, don't be afraid to just nuke them all and build them all up again.
Get too attached to the instances. Yeah.
Pretty much.
Yeah. Don't be afraid to. Yeah. Kill them. Yes.
So, sorry, this is just to clarify, you can run multiple processes on a single core.
As far as I'm aware, yes.
Cool.
Well, these are virtual cores. So the compute nodes, the physical compute nodes that your instances are running on have two 64-core AMD Rome processors.
Quick question following on from that. What hypervisor does Nimbus use, and why did you choose it?
Oh, it's the actual hypervisor is just libvirt, because it's the standard that most people use for that. Nimbus itself runs OpenStack as how it's managing all of the components. But when you boil down to what's actually running on the compute nodes themselves, essentially it's just libvirt with RBD talking to a Ceph backend storage.
Hi guys, I'm also Luke. I've just got a quick question. So part of my project involves hosting a piece of software on the instance, and ideally users should be able to access it via their own browser. Do you have any tips on setting up that connection between the instance and, say, a browser?
Well, the most important thing you're going to want to make sure is that you've actually set up a security group that actually allows access to whether it's 80 or 443, whichever port you're using for your service. Yep. So there's sorry, I'm just flying through our documentation.
There was a bit of stuff in there about setting up a web server. Is that?
There he is. There you go. So that will take you through how to create a custom security group that will allow specific services through. Now you can actually, from that, you're not even limited to the services that they list, because if you look through, then you can create a security group rule for HTTP, HTTPS, IMAP, SMTP, whatever. You're not just restricted to that. There's a section on that security group window where you're first creating up the rules, and you can just put custom ports in as required. So if you've got any kind of a esoteric service that you're trying to run that says, look, we need users to be able to connect in on this random port number for whatever reason, that's fine. You can just create a rule for it. Just be aware you don't want to sort of go too nuts and go, right, well, I'm just going to expose every port to every person on the internet.
Yeah.
It probably goes without saying. It's worth just letting people know that, because, yeah, obviously major security risks there. But yeah, that's absolutely fine to do that. I don't know what you would be running for the actual HTTP, for the actual web front end, whether you want to use Apache or Nginx or whatever. That's absolutely your choice.
Okay, thanks.
Are there bandwidth restrictions to the external internet? And if so, what are they?
So Nimbus itself has a 4x10 gig pipe that connects it to the rest of Pawsey, and then from there, obviously, to the outside world. So as far as traffic going in and out of Nimbus, any one single instance would be limited to a 10 gigabit transfer limit. But obviously there's a lot of optimization required to even get near that. I don't think we've ever seen anyone get near that. If you are creating multiple instances inside of your project that are created up on a private network, traffic on the private network is internally within the Nimbus cluster itself physically using our 100 gig switches. So you can get much bigger transfer speeds between instances in the same project, provided that they're talking to each other across a private network. So you would be using like your 192.168 addresses, for example, to do that. If you're trying to talk between Nimbus instances in the same project using an external address, which is typically one that starts with 146.118, then all that traffic would be going out of Nimbus and then back in, talking that way. So then you'd be limited by the main pipe of Nimbus.
Thanks for that.
Yeah, no problem.
No one else has any questions. I think I have one big one.
Okay.
So Isha's gone to object-based storage. What was the decision-making process to switch? Or like, what were the main motivations to switch to object-based storage? Was it the fact that you were seeing more scientific data sets being more applicable to that that object-based system? Or was it more to try and get the space-saving efficiencies of block-level storage and not having to deal with, that hierarchy?
I'm not actually qualified to answer that, I'm afraid. I was not specifically, not directly involved in the creation for Acacia. I do know there was a lot of discussion higher up about that. I don't know, Luke, if you can provide more input on that.
Yeah, I mean, I wasn't on the procurement side of things, but I think there was a range of factors that went into that decision. So yeah, I can't really give a intelligent response to that, but yeah, I think we got a good deal. So that was part of it. Part of the reason is we have a fixed budget. So obviously when we get our money, we want to make sure it goes the furthest. So I think before procurement, we try to get the best deal for taxpayers' dollars. So I think that was part of the reason, and I'm sure there was other reasons as well. So yeah, probably talking to the wrong two people here.
If you are interested, though, I mean, certainly don't be afraid to submit a question to help at Pawsey, and I'm sure you can get more qualified answers on that one, though.
I have a couple questions as well, unless someone else does.
Yeah, go for it.
Cool. So they're both sort of around, I guess like concern reproducibility and like ease of setup. So if I want to spin up multiple copies of an instance, what's the sort of best way to go about like automating, right, the installation process, any additional software, right? Is there a
So one of the options you've got is, as I've linked before, is creating a Kubernetes cluster, because you can basically pre-configure that with settings on how you want it to be set up. A potentially simpler way of doing it is to use, we have orchestration built into the Nimbus dashboard. So if you log on to the dashboard, so I can actually confirm that I'm not talking rubbish. So if you, I don't know if you happen to have a window open at the moment, if you log onto the Nimbus dashboard, if you look down the left-hand side, you'll see a section there for orchestration.
Could we, are you able to share that with the group, or if I'll find it and log in? I get the feeling that this might be useful for some of the people here.
Yes, well, actually, admittedly, that's one area that we could probably do with a bit more documentation on. But if you were to look up an OpenStack module called Heat, and look at documentation to do with that, that'll give you a lot more information on how orchestration works within Nimbus on that.
Cool.
So, but at its very basic level, you can create up a template using the orchestration tools, and then you can tell it from there, look, I want to create X number of instances. I want them to be hooked up to my private networks, that they're all talking to each other high speed, and I want one node that's going to have, for example, a floating IP that I can then just be able to SSH into to manage my network, as an example.
So writing something here would, this would be the starting point of.
Yeah, unfortunately, the system is not immediately intuitive. It's not like it's not like Lego that you can just go, oh, I just connect this and this, and hey, presto, off you go. It is certainly gives you options for things like being able to create up attached storage for your instances and all of that.
I think a lot of the time, what I'd be looking to do, right, just be to execute a series of apt-get commands, right? Once I've, once the instance is created, or once I've spun in.
Yeah, look, don't be afraid to
is it just cloning down, if I clone down a script and then run it, or? Yeah,
look, don't be afraid to be, running filthy bash scripts if it gets the job done. I'm not shameful. I will happily admit to even now that I'll, I do some of my stuff just throwing together bash scripts just to get the job done. So, it's, whatever works best for you, basically. But yeah, there are a couple of tools available that you can use for larger scale orchestration, spinning up clusters and things like that. One of them is you can use the built-in Heat orchestration tool that comes as part of OpenStack, which is available in Nimbus. And the other is, as I mentioned, using Kubernetes within, so you would create a seed node, and from there, that then runs the Kubernetes to spin up your cluster for you.
I have a question about the Kubernetes cluster.
Yes.
So would you be able to install, say I had like a whole bunch of programs that aren't available on the instance usually, and I wanted to install them all. Could I do that on all clusters simultaneously, or would I have to do that on each one individually?
Well, I mean, you can script that up to just push it all out to your cluster for sure.
Okay, cool.
whether you're using Kubernetes or even if you've just spun up your own manual cluster, and then you can use like a parallel SSH tool, for example, like PSSH or Gluster, I think is another one off the top of my head. Sorry, not Gluster, Glush. But either way, so you can have something that just sends a command out to all of your nodes and says, you know, go my pretties, install this software.
Oh, cool. Cheers.
I have another question comes to mind that just that seems related to someone who's working on Nimbus. So yeah, like a scenario is I've been working on an instance for a few months or a few weeks, and I want to and I'm transitioning to Cetonics, for instance. Now it seems like a really natural way to do that would be to build a container, right? Replicating my Nimbus instance, like that environment, and then running that with Singularity on say Cetonics.
Mm-hmm.
I'm wondering if there's anything you would recommend to someone in that circumstance, right? In terms of like identifying the the sort of def file they'll need to put together. Like what packages would I need to install, say, to build my container? Is there some way you could try to build that list if, say, you haven't kept track of that through, your usage?
Again, I'm probably not the best person qualified to answer that one. Getting into the finer details, certainly as far as, like I said, our default image, Ubuntu image that we provide for Nimbus instances that get spun up, that comes pre-installed with Docker and Singularity. So the tools are already there for you to be able to, create up your own containers and play with that as you see fit. For the purposes of trying to migrate your workflow over to Cetonics, that's more for, like I said, that's something that you will probably want to submit as a help desk query, and sort of others can help you from there. Would be my recommendation, unless Luke, you've got anything else you want to add to that?
No, not really. I mean, yeah, obviously, also it really depends on your specific discipline as well. So bioinformaticians will have specific images and stuff like that. But yeah, again, it's kind of out of my wheelhouse.
I think what I'm getting, and I'm happy with that, is that shouldn't be afraid to have a quick and dirty bash script containing the install commands that you've used that you can then convert pretty easily to a Singularity def file at some later point if you need it.
Absolutely.
The obvious solution seems like a good one for a first-time user, I guess.
Look, hats off to you if you create, a really impressive setup for being able to automate this entire process. But we are perfectly fine with if you just want to throw something quick and simple together as a basis. I mean, you can always sort of refine it from there. But yeah, don't be afraid of the filthy bash scripts, is all I can say.
Abraham, Eric, do either of you have any questions? I think we've heard from you yet.
Not for me.
No, not from my end. Maybe I was just curious about how working with these cloud services. In my laboratory, we are trying to implement them, but maybe we don't have enough information right now to use them.
No, fair enough.
I guess a question I'd have for both of you then is, what is there any like particular feature or workflow that you wish users would take advantage of a little more. Something that maybe you think is really neat or useful, but maybe falls by the wayside. Like, I guess with Slurm, I wish everyone knew about job arrays, but I know that I can't, it's not reasonable, right, to get a bunch of people into a room and say, you need to use these things. So, but just, quietly, back of my mind, I'd be an evangelist, right, if I had, for that, if I could.
Not off the top of my head. I'm more concerned on users communicating better and letting us know what they're doing and their plans. But the benefit of Nimbus is it's not your computer, because that's the big thing is, traditionally people use their own laptop to do work. We always recommend people use your laptop, not for your research. Use the cloud for your research, because you can have it running, doing your thing, and still be able to do other stuff. So
and if you royally mess it up, it's not a major issue.
Exactly.
Again, also helps if all of your data is on an attached storage volume, because
back up your data if it's really important. Don't leave it up on the cloud, because bad things happen to good people. So
yeah, look, we've not. Hang on, I'm just running through in my head. I'm pretty sure I can safely say we've not lost any user data yet. Touch wood. Yeah. But that's not something that we want people to test us on too heavily. We certainly as far as the data storage side of things goes within Nimbus, the storage that we provide for our Nimbus instances is primarily as like a workspace. Do not assume that it is backed up. If you really care about some of your data results, make sure that it's copied elsewhere. Yeah.
Great. I guess if there aren't any other questions, we're 5 minutes from the hour.
I just have one more. It's very basic. Can you just retrieve your data directly from Acacia to your computer? Do you have to go through Nimbus as like a middleman?
I believe you need to do it via Nimbus or Cetonics or whatever other system you're using within Pawsey. I'm reasonably confident. Oh, no?
You can set up a download. Sorry, Luke.
No. Yeah, no, I mean, I should be able to do it from anywhere.
So it is available externally?
Yeah, well, that's
cool. All right, well, yeah.
Yeah, I think that's one of the benefits of it is that, yeah, Acacia is the one storage to rule them all for Pawsey now, where so you can, depending if you're using Cetonics or cloud, or you're uploading data from your laptop, or you're downloading it from a repository halfway across the world. Or
so in that case, then I would suggest probably the simplest way would be to replicate whatever your MinIO client setup is on your Nimbus instance on your local desktop or whatever system you're using locally, and be able to transfer to and from Acacia that way would be my recommendation.
Cool, thank you.
And it's available for Mac, Windows, Linux, the MinIO client. So
yeah, or you can use a GUI like FileZilla or CyberDuck, or there's lots of ways you can. Although we don't support them, I've tested it and they do work as well. But yeah.
CyberDuck I have tested. Yes, you are correct.
And if you got in touch with myself, Emily, or David, we'd be happy to figure that out with you if that was something you're interested in as well. Want a second pair of eyes?
One question. I suppose it's very basic, but in my laboratory, or at least here in Cortin, we are trying to use or training with some of those cloud services such as Microsoft Azure or AWS. Do you have certain connection with that, or Nimbus and Acacia can be comparable with those services somehow?
Comparable in what way? Sorry.
I don't know, in about storage and also this kind of distribution of information that you can have a lot of information and also share and separate that information, transforming the data. Because something that we are trying to use is something called the data pools, and then transforming the data, sharing that with some clients, or create some queries about some databases that we have. I don't know if we can do something similar with Nimbus or Acacia.
As far as data sharing is concerned, I could be lying, but I think that is available as something that we can do with Acacia. Is that correct, Luke?
Yeah, I mean, they should be using fairly standard protocols. So I know I've been doing some work with Azure on another project, and they've got like behind the scenes, like, because obviously S3 is Amazon. I mean, it's a standard now, but it was obviously developed by Amazon and obviously Microsoft Azure.
Yeah,
is different, but yeah, there's definitely ways and means of sharing data between the two, because they're using pretty standard protocols. But yeah, it's not like we have a plugin for Azure or these other cloud services. You just have to download it and then move it manually. As far as
okay.
at the moment, yeah.
Okay, thank you.
Cool, right on 11 o'clock.
Awesome. Well, thanks so much, Jeremy and Luke. Yeah, doing this, it's I think I've learned a lot of interesting things. So
Yeah, no problem.
yes.
Good luck with all your projects, and have fun playing with Nimbus and breaking things and doing lots
Hopefully
of
not.
stuff.
Thank you.
Great.
Thanks.
No worries.
No worries.
Thank you.
So much.
Yeah.
See you everyone. Bye.